Genique. So here is the question. It is asked in IAS 2001. Okay, it is asked in the 2001 engineering service examinations. So observe this question. A positive charge of q coulombs is located at a point A 003 and a negative charge of q coulombs is located at a point B 00 minus 3. Then the electric field intensity at the point C 400 in the direction is the electric field intensity at a point C is in the x direction, negative x direction, positive z direction, positive x direction and negative z direction. So you have to find the electric field in which direction it is presenting. So the final electric field at the point this one, due to this one and this one, you have to find. Okay, so where in this question, the question may be simple if you understand. So how, see, observe the question. So where the point charges are located? Where the point charges are located? The point charge is located at C. On, observe this, the point charge is located at z axis. Okay, 003 means it is z axis, 00 minus 3 means negative z axis. Okay, but where we have to find the electric field intensity? At this place. So the charges are present like this. It is, let us suppose it is a z axis. If it is z axis, what about this? This one will be x axis. Okay, this one would be x axis. Okay, so now it is 0. So where the charge is presenting, the positive q coulomb, positive q, the plus q is presenting at here. This is 003 means this is 003. It is 000 and here it is presenting. Now this is one charge and another one is presenting here. This is minus q. This is 0, 0, minus 3. Understand? So where we have to find the electric field intensity? It is the point A, it is the point B. We have to find the electric field intensity at point here. Okay, we have to find the electric field intensity at this point. So how can we find? See, due to this point charge, we have to find the electric field intensity. On this point, due to this point. On this point, due to this point. Okay, so first of all, we will calculate the electric field intensity due to this point charge here. So what is the electric field intensity? The electric field intensity E can be written as Q divided by 4 pi epsilon r square AR. Here you will be able to find the electric field intensity and as well as how to find the radial vector. Okay, how to find the vector. Understand? See, observe this. So this is the expression for the electric field intensity due to the point charge. Here the 2 point charges are given. Due to these 2 point charges, we have to find the electric field intensity. So first of all, there are 2 charges. So due to this point charge Q, due to the point charge Q, okay. See, what is C point? C point is on the here. It is 400 means it is this place on x axis. So this is represented as x axis, z, x, y. So always you have to follow this notation. Okay. So EQ. So EQ can be is equals to E due to Q. Where? At here. I am finding the electric field intensity at this place due to this one. The first one. Okay. This will be equals to Q divided by 4 pi epsilon. What is R here? Okay. From here to here, what is the vector? Let us suppose this is R1, Okay, so what is this R1? This R1 is nothing but R1 is equals to, R1 is the vector, it is a vector quantity R1. Okay, R1 bar is equals to final minus initial. What is the final minus initial? 4 minus 0, AX, 0 minus 0, 0, 0 minus 3, minus 3, AZ, minus 3 AZ. So, we have to find, it is AR. It is the R1, right? Understand? It is the vector. See, due to this on this point, due to this on this point, already I told you, due to on this point, on the point represents the final point, due to this point represents the initial point. So that's why I have to take the vector from here to here. The vector representation from here to here can be written as final minus initial. Understand? What is AR1? AR1 means the unit vector in this direction is AR1. Okay, this will be equals to 4AX minus 3AZ divided by root over 4 square plus 3 square. This is 4AX minus 3AZ divided by 5. Right? This is AR1. Okay. Now I have to write here the distance Q divided by 4 pi epsilon R1 square. Okay. R1 square AR1. So this will be equals to Q divided by 4 pi epsilon R1 square is what? This is R1 square is equals to, what is R1 square? The magnitude of this one. Okay. So from this, what can I write? R1, this is equals to 5. Magnitude of this one. R1 square is equals to 5 square is 25 into AR1. AR1 is 4AX minus 3AZ divided by 5. Understand? So now this is the first one. Now what about the C? What about, so that means what? How the electric field will be? The electric field will be, if you observe this, the electric field due to, if you observe this expression, you can say that what? The electric field will be in which direction? Positive AX and negative AZ direction. What is the positive AX? It is in this direction, right? Positive AX and negative AZ direction. So the electric field, you can assume that it will be in this direction. Okay. Now, what is EQ? E minus Q. Due to minus Q at this point, how can I represent? This will be equals to what? Q divided by 4 pi epsilon. What is R square? Here let us suppose from here to here, I am considering from here to here, I am considering this one as R2. Okay, let us suppose this is AR2. The unit vector in that direction. What is R2? R2 can be written as what? What is the final point? What is the initial point? Due to this point represents means due to this point meaning is what? It is the initial point. It is the final point on this. So final minus initial. What is the final? 4 minus 0. It is 4AX. 4AX. 0 minus 0. 0 AY. 0 minus of minus 3. Plus 3 AZ. Plus 3 AZ. Okay. What is the R2 magnitude? It will be root over this square plus this square. This will be 5. Then what is AR2? AR2 is this one. The unit vector along this line. This will be equals to what? 4AX plus 3AZ divided by root over this one. Okay. Root over this one is what? 5. This is AR2. So here what I have to find? E due to Q minus Q. E due to minus Q is equals to minus Q divided by, you have to write minus here. Minus Q divided by 4 pi epsilon into R square. R square is 25. R2 square is 25. Okay. This is R2 square 25. Understand? Now what is AR1? AR1 is what? AR2 is this one, 4AX plus 3AZ divided by 5. This is equation 2. So it is the electric field intensity at this point due to this. It is the electric field intensity at this point due to this. Understand? So now the total electric field ET is equals to EQ plus E minus Q. So if we add these two, what you will get? This one and this one. Because this of this minus, these x terms will get cancelled and minus 3AZ will be there and plus 3 minus 3AZ will be there. Okay. So finally what you will get? This is Q divided by 4 pi epsilon 25 is common in the both terms. Then here you will get minus 3AZ minus 6AZ is the final answer. So that means what we have to find? What we have to find? We have to find the direction of the electric field intensity at this point. What is the direction of the electric field intensity? Is it negative AZ direction? Negative AZ direction. So this is the thing. Understand? So what is the option? Option here is this one. Understand? So this is the concept. You have to, it is the concept. Okay. Now, so without solving all these things, so can we do anything? Smart work. So observe this. We got the answer, but from the figure, if you visualize the figure, so for this kind of question, for solving this kind of question, the figure is not needed really. Understand? Because the 2 points are given. The 2 points are given, and from here to here you have to find and a distance. From here to here you have to find the distance, and you can also find the from here to here the unit vector, from here to here the unit vector. For this problem, the figure is not at all needed. Okay? The figure is not at all needed to solve this question. Okay? But the thing is, why we have drawn the figure means, without solving this, if you are able to draw the figure, so without solving, you can easily identify the answer. Understand? Why I have chosen means, this is the, why I have chosen this question means, this is the case. How to do in the examination if the questions like this are given. See, observe this. You forget about this entire analysis. We have taken, what we have taken? The question is given as the point is here. On this point, Q is present like this. On this point, minus Q is present. We have to find the electric field intensity at this place. Understand? So now, see, you have to know that, see, the positive charge is the source of electric flux lines, right? So from this, we can say that the electric flux will be like this, due to this point charge. Okay? So in this direction, I have to find the electric field at this point. Understand? Now, you have to observe one more thing. Observe this. Here is one more thing. But here, you should know that it is a negative charge. The negative charge will be having the sink of electric flux lines. Understand? It is a sink of electric flux lines. So that means it will divert the electric field and it will converge the electric field. So from that, what we can say? From this, what we can say? The electric field here, it will go here and reaches here and it will come here. We can say like this. Understand? It is the electric dipole concept. Okay? These two positive and negative charges are separated at a distance. That means if the two positive and negative charges are separated at a distance, what happens? What happens? The electric field will originate at the plus Q and end at the negative Q. The electric field originate at the plus Q and end at the negative Q. The electric field originate at the plus Q and originate at the negative Q. So this is the concept of electric dipole. Okay, so that means, observe this. So what is the field direction for this? The field direction for this is what? The field direction for this is what? This direction and this direction, right? Okay, this direction is what? This direction is AX direction, this direction is minus AZ direction. Understand? Minus AZ direction. Now observe this. How the electric field is coming? The electric field is coming in this direction. So I can also take into the vector components like this. This can be, see, this is the vector field coming like this because it is a negative charge. So that means I can take the two components here. One is in this direction and one is in this direction. Understand? So this is what? A negative Z direction and it is negative X direction. It is AX. What about this? This is negative AX direction. Understand? Now what happens? These two are equal and opposite. While we are adding, what happens? The magnitudes are equal and opposite. The magnitudes are equal and opposite and they are adding means what happens? And they are adding means what happens? And this can be cancelled. AX term will be cancelled. Understand? Only what we will get? You will be having a negative AZ term and a negative AZ term. And these two will be added. Okay? When you are adding the fields, two fields due to this one and due to this one, these two will be cancelled because one is negative X term, one is negative X term, positive X term. These two will get cancelled. So here you will get what? Only the negative Z terms. So without solving this, within a minute, you can solve this question without solving this entire thing. Understand? So this is a very good problem. So like this. Next problem. So observe this question. See, if you come to this question, what is that question? There are 3 point charges are given. 4 coulombs, 6 coulombs and minus 24 coulombs are located at 102, 4, 3, minus 2, 5, 4, 6. Okay, respectively. Okay, then find the total flux leaving the spherical surface of radius r is equals to 4 meters. Okay, with 203 as the center. See, observe this. So what is this question given? So this question is related to what? You have to identify. Okay, there are 3 charges are given at 3 places. Okay, so what we have to find? We have to find the total flux leaving the surface. Which surface? It is a spherical surface of radius r equals to 4 meters with 203 as the origin. Okay, the center. Okay, the center of the sphere. So write this one as the center. The question here is the center of the sphere. Okay, so now you have to assume one spherical surface. What is the center? The center of the sphere is 203. Somewhere it is the 203. Okay, it is in the xz plane. Okay, now observe this. So what is the radius of the sphere? The radius of the sphere is what? R is equals to 4 meters. So where these all points are located? If you observe this, what are these points? The first point is what? 4 coulombs. The 4 coulombs, where it is located? The 4 coulombs, where it is located? The 4 is located at 102. And 6 coulombs is located at where? 4, 3, minus 2. Okay. And minus 24 coulombs are located at where? 5, 4, 6. Okay. These are located. Okay. These are located at these points. Okay. These are located at these points. Now we have to know what he is asking. He is asking the total flux leaving this spherical surface if these 3 charges are placed at these points. Okay, we know Gauss law. What is the Gauss law? The Gauss law is saying that the total electric flux leaving any enclosing surface is equal to the charge enclosed in the volume. The charge enclosed in the volume, you have to note that. So you have to identify which charges are inside the volume. What is this volume? This spherical volume. So you have to decide which point charges are inside the volume. Understand? So now you have to see, observe this 102. So to determine 102 is whether it is there 102 within the sphere or not. What we have to do? Within this volume, what is the sphere? This is the sphere of radius 4. This is the sphere of radius 4, but its center is 203. Okay, so how can we find whether this point is inside this 4 meter radius or not? Okay, how can we find? Suppose if we find the distance between from here to here, okay, from this point to this point, what happens? Suppose if we find the distance, let us suppose it is located at R1. Suppose if I find R1, due to this, R1 is equals to what? Root over from this point to this point. What is this? What is the distance? The distance here is 2 minus 1 whole square plus 0 minus 0 whole square plus 2 minus 3 whole square. You can write like this. So what is this value? This is root over what? 1 plus 1 square. 1 square plus 1 square. This is root 2. Root 2 is less than the given 4. Right? So root 2 is less than this radius. Understand? So that means this point is inside the circle. Inside the sphere. So this is presenting in this. Understand? Why I am writing this? The 4 coulombs must be present within this r equals to 4 meter radius. Okay, how to find whether it is presenting in the r equals to 4 meter radius? Suppose if we find the distance between this point and with respect to origin, if it is greater than 4 means it will be outside. Okay, with respect to origin, if you find the distance, okay, if it is greater than 4 means the point is outside. Understand? Like this. So the 4 coulombs is inside somewhere. Okay, the 4 coulombs is inside somewhere. Now, so what about this? Come to the second one. What is the second one? R2 is equals to root over this minus this. 2 minus 4. 2 minus 4 whole square plus 0 minus 3 whole square plus 3 plus 2 whole square. So this is equal to what? This will be equals to root over, what about this? 4 square, it is 4, it is 9. Okay, 2 minus 4 whole square, it is 2 square, it is 4, it is 9. What about this? This 5 square is 25. It is greater than 4. So that means what can I write? This is outside the sphere. If you take the distance from here to this point, what I am getting? The radius is outside, greater than 4 means what? Outside the sphere. So it is somewhere. Let us suppose the point is here, 4, 2, 3. This is 6 coulombs is outside the sphere. Now, what about R3? R3 is equals to what? R3 is equals to root over this minus this, right? 2 minus 5 whole square plus 4 minus 0 whole square or 0 minus 4 whole square plus 3 minus 6 whole square. So this will be what? Root over, this is 3 square, this is 4 square, this is 3 square. Again this is greater than 4. We are getting greater than this 4. Means this is also outside. Right? So this is also outside. That means let us suppose this is somewhere minus 24 coulombs is outside this given sphere. So what we have to calculate? We have to calculate the total flux leaving this surface. So we have to calculate the total flux leaving this surface. What is this surface? Spherical surface of radius 4. Okay. So the total flux leaving this closed surface is equal to the total charge included in this surface. Okay. What is the charge included in this? The charge present in this surface is only minus 4 coulombs. Sorry, it is not minus, it is 4 coulombs. Okay. So the net flux leaving is equals to, the answer is the net flux or the total flux leaving is equals to what? 4 coulombs. This is the answer. Understand? This is the answer. I hope this is clear. Understand? So now, so the net total flux leaving is equals to 4 coulombs. So only this 4 coulombs is present inside the given volume, given sphere. Okay. So this is the answer. Suppose if the point is, if the radius is, let us suppose some 100 meters. What happens? Suppose the radius is 100 meters, or let us suppose the radius is what? Some 50 meters. What happens? It is less than 50, it is also less than 50, it is also less than 50. Suppose if the radius is 50 meters, what happens? What happens? These all are inside the 50. Less than 50. It is less than 50. Okay. In the when compared to the previous question, only the radius is changed. Okay, the radius, if the radius is 50 meters, what it will be? Okay, for this one, it is inside. It is also inside. It is also inside. So that means all are inside the sphere. Okay, all are inside the sphere means what? All are inside the sphere. That means 4 coulombs and 6 coulombs and 24 coulombs are inside the sphere. So what will be the total net flux leaving? For this question, what will be the net flux leaving? The charge enclosed in the volume. Okay, the charge enclosed in the volume means it will be 4 plus 6 plus, it is 24. This will be, this is 30, 34 coulomb. Sorry, this is minus, right? This is minus 24 coulombs. It is minus 24 coulombs. It is minus 24. This will be minus 14 coulombs. Okay, minus 14 coulombs. Minus 14 coulombs is leaving. What is the net flux leaving the surface is equals to minus 14 coulombs leaving this spherical surface. Minus 14 coulombs leaving means this is equals to 14 coulombs entering. 14 coulombs entering. What is the net charge in this? The net charge in this is negative. The net charge in this is negative. Understand? If you find the sum of this, the net charge is negative. The net charge is negative means what happens? The flux lines come from outside and it has to converge here. Understand? So that's why you can also say that for net flux leaving is minus 14 coulomb, or otherwise you can also say that 14 coulombs is entering this region. Understand? So this is the concept. Understand? So by observing the question, it may look very simple, but how to use the Gauss law and how to visualize the question is very important. Okay, so like this, suppose in the given question, if in the given question the question is kept same, okay, if the question is given this, let us suppose with origin as the center, with origin as the center. In the given question, he has given that the 3 point charges are, observe this, previously it was 4, right? It was 4 meters. Okay, so this is the question given. What is that question? The question given is the 3 point charges are this with origin as the center. Okay, there is a difference between origin and center. That's why you have to identify this. What is the origin as the center? See, when compared to the previous question, this point is not given here now. So it is not the center now. What is the center? The center here is 0, 0, 0. The center here is 0, 0, 0. And the radius of the sphere is 4 meters. The radius of the sphere is 4 meters. So this is the question. So how can you identify, how can you find the total flux leaving this? How can you find the total flux leaving? Observe this. The points are kept same places, but I changed the surface now. But the surface is of same sphere, but the origin is at the center is at the origin. Okay. So how can you find? So similar way in the previous case. Okay. If that is solved, and it can be easily solved. Okay, what we have to find? We have to find the R1. So we have to find the distance from here to here. The distance from here to here is equals to what? This minus this or this minus this. This will be 2 square plus 0 square plus 2 square. This will be what? Root over, this is root 5. Root 5 is less than 4. Now what is R2? R2 is between from here to here. Less than 4 means what? It is inside. Okay. So why we are calculating this? Whether we have to find these points are inside the given sphere or not. How can we find? By finding the distance from here to the given point. If it is greater than 4, it is outside. Less than 4, it is inside. R2 is equals to root over this minus this or this minus this. This will be 4 square plus 3 square plus 2 square. It is greater than 4. By observing, we can say it is greater than 4. It is outside. Now what about this? R3. R3 is the distance between from here to here. This will be equals to 5 square plus 4 square plus 6 square. It is also greater than 4. It is also outside. These two are outside means these two are outside. So these two are not included. Only 4 coulombs is included in the given sphere. So the net flux leaving equals to 4 coulombs. So like this we have to approach these kind of questions. Okay. So this is for the point charges. Now suppose if you come to the line charge, how to approach with the line charges? Suppose I am writing the question, a line charge of rho L is equals to some 10 nanocoulomb per meter is located at y is equals to 3 and z is equals to 4. Y is equals to 3 and z equals to 4 for all x. In the surface defined by x comma y comma z is less than 10 meters or 10 units. Okay, so this is the question. It is the question given. So we have to find the net flux leaving the surface. So this is a line charge is located like this. Then the question is find the net flux leaving the surface given. What he has given you have to identify. He has, in the previous case the question was about the point charges, but here the question is about the line charge. How to find this kind of problems? Okay, how to find the net flux leaving the surface here? So you have to identify the surface and you have to identify the charge. You have to identify whether the charge is inside the volume or not. Okay, so this is the line charge and this is the line charge. sorry, this is the line charge and it is the surface, and this line charge is placed here and the line charge is placed there. Okay, now how to visualize this question? See, it is the line charge is a line charge is rho L, means it is not mentioning it is a finite length charge. Until unless you mention the finite length charge, you assume this charge as the infinite length only. Okay, infinite length only. Right? Now, observe this. So, how can you find this type of question? See, observe this. So, first of all, how to identify this? How to first of all draw the surface? Draw the surface. What the surface has given? The surface has given x, y, z are between minus 10 and 10. Sorry, this is minus 10 and 10. The question is minus 10 and 10. Okay. So that means x is in between minus 10 and 10. Y is in between minus 10 and 10. Z is also in between minus 10 and 10. That means it is a rectangular box. Okay. It is a rectangular box. So how can we find it is rectangular box or not? So we can visualize this. So observe this. It is a rectangular box. Okay. Now within the rectangular box, it is placed here. So one line charge. So it is placed in y equals to 3, z equals 4. So that means it is placed in x, z, y, z plane. So y, z plane means observe this. It is y, z plane. It will be y and it will be z. Always you have to follow. It is y means it is z. What about this? This is x. You have to follow this. And x, y, z are. So observe this. What is this? The first of all draw the surface. The surface is from minus z to minus 10 to plus 10. Okay. This is plus 10. Y is from minus 10 to plus 10. And z is from minus 10 to plus 10. And x is from, what is x? This is x. X is like this, into the board and out of the board. Okay, it is a rectangular box from the front view. Okay, there also back side there is a rectangular box is existing. Okay, so now where this is x, this is the x axis. Now where the rho L is present, the rho L is present at y equals to 3 and z equals to 4. Y equals to 3 means where? It is x equals to 0. Okay, y equals to 3 means it is 0, somewhere it will be. It is y equals to 3. Okay, z equals to 4. Z equals to 4 means somewhere it will be. So here it is z equals to 4. Like this. Okay. So here at this place, what is this? It is line charge. Line charge is placed for all x. See, I have to place the line charge. Line charge means it is infinite line charge. Okay, infinite line charge. Okay, or for our questions, you can also include this is an infinite line charge. In general, he will write infinite line charge. He will not mention, means you have to assume that it is an infinite line charge. Okay. Now it is placed like this. So an infinite line is placed like this. This is the thing. For all x means from minus infinity to plus infinity. Okay. So it is the line charge like this placed here at this place. It is the place within this surface. Within this surface at this place, this charge is placed. Okay. What is this charge? This charge is rho L is equals to 10 nanocoulomb per meter. Line charge. Okay. It is given. It is the line charge. Now you have to find the total flux leaving the surface. It is placed in the surface only, right? But the line is from minus infinity to plus infinity. Okay, if the line is from, suppose if I write the side view, if I write, so this is the line, suppose if I see this line from the side, how it will look like? How it will look like? The side view will be like this only. Okay, side view will be, from the side view I can visualize x, because it is x-axis, right? If I see from the side view, it is x. Okay, this is from plus 10 to minus 10. Okay, somewhere it is located. What is this? Somewhere it is located. It is a line charge. It is royal. It is from minus infinity to plus infinity. But how much line is existing? See, it is from minus infinity to plus infinity, right? How much? It is how much? 10 nanocoulomb per meter. How much charge is existing in between? Means how much line charge is existing in between the rectangular box? How much? It is from minus 10 to 10. How much length? Minus 10 to 10. So it is the line charge. This line charge is distributed over the length. So to find the total charge within this, I have to multiply. This is coulomb per meter. If I multiply with meters, means if I multiply with the distance, I can get the coulombs, means charge. The charge can be written as rho L into the length. What is the length? Here the length is equals to 10 minus 10. It is 20 meters. Okay, here you have to write this meters. 10 meters, 10 meters in the question. Okay, 10 meters, 10 meters. It is 10 meters and 10 meters. Okay, so now what it will be? So this will be, what is Q? What is the total charge? The net flux leaving. This is equals to what? Net flux leaving is equals to the charge enclosed in the medium, QNC. What is this? Charge enclosed in the volume. What is the charge enclosed in the volume? Only this amount of line is present in the volume. So that's why I have to take this portion only of length 10 meters, 20 meters, of length 20 meters, and you write 10 nanocoulomb per meter. Per meter will get cancelled. So this will be 200 nanocoulomb per nanocoulombs. It is 200 nanocoulombs. So like this. So what is the net flux leaving this given surface is 200 nanocoulombs. Understand? It is also the Gauss law. Okay.